Hey guys, welcome back. Some of you may already know what this is, and this is a DSO150 from JYE Tech. It's a handheld oscilloscope that has the drawback of it actually needs power through a cable. So what I'm going to do today in this video is modify this DSO150 so it gets to a true handheld state. We can actually use it without having the additional tether going into a power supply. And everything you need for that is essentially 3 components, 4 if you consider a switch to be an extra component, or 5 if you consider this to be a component. So let's start. We need a DSO150 obviously, and I already mentioned a switch. Then we need a battery, and I decided on using this new smartphone battery. They are much cheaper than these small silver lithium-ion cells, and the only drawback is that they can't draw high currents, but as this thing just uses a few hundred milliamps, that's absolutely no problem. Then we need a boost converter to step the 3.7 volt up to 9 volt, which this thing needs. And we also need one of these over here, and this is a BMS with charging circuit for the lithium-ion cell. Now let's open this thing up and I will show you how everything will go together. So I already removed the screws, and we can remove the top part. Just like that. Be really careful not to damage it. Okay, and that's the inside. So when I remove the bottom part and I again get this thing together, we can take a look inside, and you will see that there is plenty of space. But it might look more than it actually is, and it was quite quite difficult to get all of these components inside. I was almost at the point that I had to remove this potentiometer over here to get it small enough, but I was able to fit it inside. I just removed the pins of the bottom over here and a few pins on the other side of this part of the oscilloscope. And as you can see here, I already marked where the battery is going to sit in, and this is the position. Well, you could position it like this, but I wanted it to be a bit further away from the analog side of the oscilloscope so that there's no way of anything shorting out. And then we will insert the charging circuit over here, and this is, I made a cutout on the side and a cutout for the switch. The switch will go in here just like that. The charging circuit, well, actually the USB port goes out as far as possible. Removed a bit of material from the inside. And then we have the boost converter, which will go in like this. I think it was all the way to the side. And then it's just a thing of connecting everything accordingly and to the shield over here. What I'm going to do is, I think I might use this over here, or maybe this connector, these leads. I'm not 100% sure. I have to see where I can come close enough so I can solder properly. Okay, let's start with the bottom side. This is the easiest part. Easy in quotation marks. Now, this battery has 3 connection points, and we have to measure to see which ones are the ones for battery voltage. The other one is a sense pin or a data pin. I'm not 100% sure about that, but between 2 of them is a voltage, and between these 2 and the other pin there's no voltage. So we got between the outer ones 3.87. If we use these, there's no voltage. If we use these, there's again 3.8. So normally when I do these measurements, one pin has no reference at all to either side. So I will just use the outer 2. I think that's fine. If not, I just have 2 switch connections, and I will use the tiniest wire possible. This is that I have. Actually, there are wires that are smaller. This is 0.14 square millimeters, so really, really tiny. Just cut off a piece of wire, attach it onto here, and then I will set it aside and shorten the wires as needed. So when you try to solder onto any lithium-ion battery, or actually any battery, doesn't matter what kind, you try to do the solder job as quickly as possible so you're not heating up the actual cell. This could damage any battery. Now, after I soldered the leads, I will now test the battery voltage to make sure that there's electrical contact and to make sure that I haven't damaged the cell. This is negative and this is positive. Yeah, and we have still 3.87 volts, so everything is fine. I was quick enough, and we have electrical connection. Next, I will bend up these wires, and I need some Kapton tape to insulate this connection. Okay, that's plenty. Now we'll get the battery inside and see where the switch is going to sit. Switch will sit like this, and I think I will switch the positive side. So positive will be really short. Now before I go ahead, I will use another piece of tape. Get this underneath here. Apply some solder to the switch. Get this back onto here. Now I'm going to pre-tin the wire. And again, back in. Now this is going to be interesting. All right. Now the battery and switch are done and are firmly held in place with Kapton tape and properly insulated. I will now stick down the battery with a piece of double-sided tape. Okay, this is done. Next up we have the BMS and charging circuit. This will go in here just like that, and we need these 4 contacts over here. We have B+, B-, and we have out plus and out minus. So we'll use a piece of heat shrink. Now this goes over the charging circuit, and that should be fine. Everything is protected and we are not going to short anything whatsoever. Now again I need a piece of double-sided tape on the bottom and stick it down. Okay, so then we have to connect the leads, but first I have to shorten them. And this is positive, so this goes to B+. This is negative, goes to B-. Okay. Well, it's not a big deal, it's just a bit of insulation that's damaged. But I will just insert a piece of Kapton tape underneath. The other cables are properly insulated, so there's not a big deal. That's really unfortunate, and it happens when you overheat these tiny wires. It can easily happen, but just make sure that there's no short. Okay, now I will pre-tin the other pads. Plus outgoing, minus outgoing. And now comes the boost converter. Now the boost converter goes in like this. Well, actually the other way around, but we have V in plus and V in minus over here, so we'll do it like this. Now we need a piece of heat shrink to make sure that this is also properly protected. Have to make an opening for the potentiometer so we can adjust it. This is VN plus, and VN plus goes over here. I will also make these wires as short as possible. And again, a piece of wire has to go. Okay, and this one goes over here. Perfect. And if everything is wired correctly, we should get 9 volts out of the boost converter, because I have the boost converter preset to 9 volt. And turn the switch on, and we should see 9 volts. That's 10. Okay, everything is wired correctly, just the voltage is wrong, but that's not a big deal. If I turn it off, everything should be turned off, and it is. Perfect. So these I will use to connect the top part with the boost converter. Okay. And now I can get the heat shrink on top. And just like that, we are done with the bottom part. Except I have to use a bit of double-sided tape again. And now I have to route the cable for the top part. But first, let's measure the voltage again and trim the voltage, so that we are good to go and not causing any problem if for whatever reason I have the switch turned on and 10 volts would go in. I'm not 100% sure if this would damage it right away, but it says 9 volt DC on the outside, so I don't want to risk it. And also we make sure that the polarity is right. Now we go to voltage, turn it on. .6 volt. Well, that's weird. Why 1.7 coming out? I don't get it. What is going on? Okay, this BMS and charger behaved a bit weird, so I decided to swap it out for another one, and hopefully this will work. Okay, so this was a lot of work. I first changed the BMS/charger, no result, didn't change. Then I shorted out the 2 battery connections that had the same potential, no change. And now I think what is the problem is inrush current. For some reason this boost converter has such a high inrush current that the BMS says, oh no, that's more than 2 amps, I will not deliver voltage. However, for some reason it delivers 1.7 volts, but normally it shouldn't deliver any voltage, but it does 1.7 volts. So the only thing that I have, the only explanation would be the inrush current. But why it behaves that way, I have no idea. And it also does not light up when I turn the switch, it doesn't light up. But when I use the charger, both LEDs light up, which is also not how it should behave. But that's okay. I mean, it now works when I have this over here, use my multimeter, and I'm now turning it on. It just gives 9 volts most of the time. And I say most of the time, it's not always, most of the time. And yeah, it jumps for a short moment to 13 volts, but that's not a big deal. Turn it off, turn it back on. So it's pretty reliable. Sometimes it's not as reliable. What could also be, but I'm not sure why, then this should only deliver like 1.7 volts, is that the switch is a bit well, it doesn't make good contact. But why should this then deliver just 1.7 volt? I have no idea. So it's a mystery, but it works for the most part, so I will now install it back in. And I decided not to use heat shrink on the module because well, I was working on this circuit and I just decided to use a bit of Kapton tape to hold it in place. Now I will again stick it down with some double-sided tape, and we'll come back when I'm finished with that. Now that the battery is back in, the last thing to do is to route this cable to the top part. And when I turn it like this, we can see that the white connector is on the other side. So what I'm going to do is to route the cable over here, like this, and shorten it the way that I can lay it out just like that. So I will shorten it, and I can just do it like this. That should not be too long, and there's also nothing it could short against or it could rub against, so that's fine. The only thing it can rub against is the top part, but that shouldn't be a problem. And I now noticed, oh no, this part is in the way, so it has to be routed like this. Oh, okay, that's a problem. I think. Let me see. No, it does not fit underneath, so... Oh, that's a problem. No, so this connector is not going to work. These cables are just way too thick. So I have to remove them and use smaller cables. And I don't know what I can use as a connector. Maybe use this one, but have to use smaller cables to route it differently. I could route it down here and use some Kapton tape to make sure that it doesn't short. And I think that's exactly what I'm going to do. Oh no. I have to remove the heat shrink from the boost converter. It's not going to work because it adds too much height. Now I'm going to use a piece of Kapton tape on top over here. That's much more work than I thought it would be. Well, primarily because of all the safety features that I used, the additional heat shrink and everything. It's such a pain if you try to make it safe, but it actually makes your work harder. What I will do is protect these capacitors like that. And I will remove the top piece. That should be fine. Yeah. There are some traces underneath. These I'm going to protect. I think I might just use a lot of Kapton tape over the whole input area. Oh well, my smartphone battery just died. But I decided to work on the DSO150 to finish this project. This took much more time than I thought it would because of all the small problems I ran into. The heat shrink being too thick and also the module having a weird behavior, and it still has. If the DSO150 sits for some time and I turn the power switch on, it will not light up. And if I turn it off and back on again, it will turn on. And it will turn on until it's set for some time in power off mode. And I think it has something to do with Inrush Current, but I'm not 100% sure. Maybe this thing has some internal damage. I mean, this was just playing with the Kapton tape over here. So I finished soldering the connector to the output side of the boost converter and to this 2-pin connector. I made sure that this 2-pin connector is actually connected to the power rails over here. And I use this as these are the contacts that I can get really close to and easily solder to. I have the 2-pin connector over here encased in a bit of Kapton tape. The reason for this is these two open contacts, so there's no short that can happen. And also it will hold the 2-pin connector a bit tighter. Beside that, I installed a small indication LED over here, so I know that I have actually turned on the power, because if I turn this switch, it's just the power that is turned on, not the DSO150. I have to turn this switch additionally so this turns on, and I like this better than just cutting some traces and rigging up this switch over here. You can't do that. There are modifications you can do, cutting some traces and using this switch to actually power on everything. But I like it this way, so I don't have to modify the traces and potentially damage the DSO150. So the LED gives me an indication when it's turned on, and I also made a small hole under here, so this lights up whenever the power is turned on, just like that. And from the outside, it's a nice blue, small blue LED, a 3-volt LED with a 680 ohm resistor in series. Now we can finally assemble everything. Oh man, this project is just haunted, honestly. So what happened was, when I assembled everything and I applied pressure exactly over here, the thing would just turn off. No power. And I don't know why. I first tried to insulate everything over here, no result, and I insulated these things because I thought there might be a short. I insulated everything, but it was not a short. Then I thought, well, let's remove the connector. Maybe it was the connector, and it wasn't the connector. It still didn't work. Then I noticed that this rotary encoder wasn't sitting properly against the PCB over here. It was just a few, I don't know, hundreds of a millimeter not sitting completely flush against this PCB. I reflew it, it dropped down a bit, I rescrewed everything, and suddenly it stopped behaving like that. But I have no explanation, because this thing is just a rotary encoder. And what happened was, when this wasn't connected, when the top part wasn't connected and was pressing around over here, nothing happened. But when this was connected, somewhere there had to be a short. But these pins were not shorted. There was no short on the top PCB. But it seemed dropping down the rotary encoder solved the problem. I don't know why, but it works now. So when I now assemble it, we can finally test this haunted project. Okay, so everything is screwed together, and now I can actually turn it on, and it works. Nice. Now it's a true handheld oscilloscope, although it's a oscilloscope. Just powering on the DSO150 is not really a test, so what I'm going to do is hook this thing up to the DSO150, and we can see a square wave signal from the NE555. This is an NE555 that drives a bigger MOSFET, so this thing is designed for motors or for LEDs. It's a pretty simple circuit, just the NE555 as a stable multivibrator, producing square wave signals that get feed into a MOSFET that can handle a much higher current. The question is, which is the input and which is the output? I will deliver 9 volt and limit the current because I don't actually know if this is the right connection. However, let's see. Turn it on. Now we get some signal. Do we? Oh, yeah, okay, so I have to actually turn the potentiometer so we get a square wave signal. It's not perfect because the probe isn't trimmed, and also the oscilloscope itself, I didn't do that. But it works. No wire. Completely battery powered. Nice. So this thing will be used in future projects when I need an oscilloscope. not just because. Although I ran into many problems modifying this DSO150, I'm really happy with the result. It took a lot of time, I ran into many problems, but that's just how it goes. It's not always running as you planned, and some things are just I dry fitted all the components, and yeah, then I used heatshrink. That was a mistake, and some of the components weren't behaving, and still there's this slight bug, I would call it. If I turn it off for too long and turn it back on, I have to turn it back on 2 times before it actually powers up, for whatever reason. It has something to do with Inrush Current, but I don't actually know, because as I said, the BMS delivers 1.7 volts. That's just weird. Maybe it's damaged, maybe that's the problem. But I will keep it as is, because it works. I mean, turning on the switch 2 times, it works, there's nothing wrong. And now it's a truly handheld portable oscilloscope. So if you like this project, please leave a like, comment down below. And other than that, thanks for watching and see you next time. Bye!